This was the pre-release material for question 11, and there's a couple of key bits in here that we needed to use in the question. So it asks about the extinction coefficient, and it tells us here about how we can calculate that. And also the last part of the question talked about the Secchi depth as well. Hopefully, if you've done the work beforehand using the pre-release materials, these ideas felt fairly familiar. So in the first bit here, we've got a graph drawn, and it's a logarithmic graph. We can see going up the y-axis here, every time it's going up by a multiple of 10. And remember, as we've seen before, we use this with exponential graphs where it's really difficult to read some values off, but using a logarithmic scale allows us to do that. Now, across the x-axis where we've got the depth in meters, this is just a regular linear scale, just going up by 50 each time. So we read that one off normally. We've got to be careful when we're reading from the logarithmic scale, and we'll have a look at the next part of the question when we need to get into that more. So what we're being asked to do here is finding the intensity of sunlight at a depth of 360 meters. So reading it off the linear scale here, it's going up in tens. Now we can't read it from the line here. So what we need to do is extend the line. We use the fact it started off as a straight line to know that it will continue that way. And then we can draw from 360 meters up to the line and then across. And if we put it in this place, reading it off is really nice and straightforward. It's 0.01. You may have found yours came out a bit higher or a bit lower. Remember the way logarithmic scales work. So this next line here would be, let me just get rid of these bits. So this next one would be 0.02 and 0.03. And we can see the gap between these changes, but each line shows us, in this case, the next hundredth up, or in this case, the next tenth up. So the answers that were allowed for this were between 0.08 and 0.012. Said you had to show on the graph how you did this. Now, you got a mark just if you got an answer in this range, because you were trying to do it off the screen in most cases. But in an exam, you would have been expected to show the line being extended and then the line going up and across to read from it. The next we had to do here involved the extinction coefficient, and it kindly said that it's defined in the pre-release material, so you know to go there to look for it. And this was the key bit for working it out. So the extinction coefficient, it's saying sunlight at the surface, if we think of that as 100 units, we need to find the depth at which the sunlight intensity is reduced to 37 units. So 37% of what it is on the surface. And then the extinction coefficient is a reciprocal of this. Remember, the reciprocal just means 1 over the number. So here it needs to be in meters, which is what we've got here. And we're asked to use the graph to estimate the extinction coefficient for unpolluted seawater. So we need to find where 37 units is on the scale here, because we can see it starts at 100. So here's 10. Remember, with this semi-log graph paper that we've seen before, each one of these lines represents the next 10 going up. So that's 30 there. The next one up there will be 40. So 37 is somewhere between them on this scale here. Now, it is hard to see. We can go for 37 being about halfway in there. If we draw our line across from there and then down, remember the x-axis on the bottom is just a regular linear scale, so we can read that normally. So that just comes out there as 40. Now, we've then got to find the reciprocal of this. So it's 1 over 40, and the units are meters to the -1. We can leave it like this, or we could do that and work it out as a decimal. Either is absolutely fine for that. And that comes out as a decimal. Now, the range of values you're allowed for this, we could have had, where we read it off as 40 meters, that could have been anything between 35 and 45. And you got a mark for showing you read that off the scale. So the limits the mark scheme would allow this as a fraction or a decimal, or this as a fraction or a decimal for the lower end there. In part D, we're told what the extinction coefficient is, and remember this extinction coefficient is equal to the reciprocal of the depth where sun intensity is reduced to 37 units. So this divided by the depth. Now, the information we're given here is that the extinction coefficient is 4, so that's equal to 1 divided by the depth, where sunlight's reduced to 37 units. So if we rearrange that, multiply both sides by depth, divide both sides by 4, we get 1/4 of a metre, or 0.25 of a metre. Says in the question though this must be in centimetres, so you had to get the answer 25 centimetres to get the mark there. The last bit moves away from the extinction coefficient to look at the Secchi disk. So the information it gives us here is it's lowered in. We know it ceases to be visible at 4.5 metres, becomes visible again at 4.3, and the key bit of information from the pre-release material was this. We just need the mean of these two, which gives us the Secchi depth. So if you wanted to show the calculation, it's adding them together and halving it. And that's just halfway between the two numbers. So 4.4 metres. And the mark scheme said you had to put the units in here to get this 1 mark. Without the units, you did not get a mark.